One thing I didn't mention before is to do partial fractions, what you need is the denominator needs to have higher degree than the numerator. And if they don't, then what you have to do is use polynomial division to make it so that the denominator has bigger degree. So let's see, this one we've got a cubic on top of a quadratic. So first up, let's do the division. So I'm going to do, let's see, we're doing x cubed plus 2x minus 5 divided by x squared plus x. If it's been a while since you've done this, it might be a good little review here. I'm skipping some space here because I'm leaving some space there for an x squared term that's not there. So we look at this and say x squared times what gives you x cubed? Well, the answer is x. Then you do x times this gives you x cubed plus x squared, and then you subtract. What's that give you? X cubed minus x cubed gives you 0x cubed. This gives you minus x squared. I'm going to go ahead and bring down the rest of this. All right, now x squared goes into minus x squared, negative 1 times. Multiply the negative 1 times this, and we get minus x squared minus x. And now I want to subtract this. All right. So minus x squared minus negative x squared gives you 0. This is 2x plus x gives you 3x. And then the negative 5 just comes down, so we get this. Now, if we say x squared times what gives you 3x, the degree of this is bigger than the degree of that. So we stop here, and this is our remainder. So what we can do is rewrite this integral as x minus 1 plus 3x minus 5 over x squared plus x dx. So that's our first step, is to do all this division to rewrite our integral. Now we've got an integral that we can do partial fractions on. How can we factor this? Well, x squared plus x, that factors into x plus 1 times x. So let's do partial fractions. 3x minus 5 over x times x plus 1 equals a over x plus b over x plus 1. And I'm going to multiply all this stuff by x and x plus 1. And when I do that, we get 3x minus 5 equals a times x plus 1 plus bx. All right, let's use the plugging numbers in technique. If I plug in, the thing I want to plug in is 0 to 0 this way, and I want to plug in negative 1 to 0 this way. So let's, I'll do this in purple. If x is equal to negative 1, then over here on this side we get negative 3 minus 5 is negative 8. And over here we get, let's see, that's going to go away, and we get negative b. So immediately we've got b equals 8. Now if we plug in x equals 0, 3 times 0 minus 5 gives us 0. No, it gives us negative 5. And on the other side we get a times 0 plus 1. So it gives us a equals negative 5. So I can rewrite my integral now from up here. I'm going to rewrite this as integral of x minus 1. Let's see, a is negative 5, so this is going to be minus 5 over x. Let's see, b, we've got x plus 1 on the bottom. B was 8. So this, oh, sorry. So this is what we've got. X minus 1 minus 5 over x plus 8 over x plus 1. And now this is something we can just integrate each term of easily. You get 1/2 x squared minus x minus 5 ln absolute value of x plus 8 ln absolute value of x plus 1 plus c. That's it.